I'm going to do a angle beam calibration using a Rompus block. The equipment I have today is an Olympus Epic 1000i UT machine. I'm using a 45-degree screw-on wedge, a GE 2 1/4 half-inch diameter transducer, and of course I put coupling between the wedge and transducer and screwed it down. And then I'm going to use the Rompus block to calibrate with and to check the angle of my transducer. And the Rompus block can be calibrated using a 1-inch and a 4-inch reflector. Here's the zero marking machined on the block. From the zero, we have 1 inch going to this radius is 1 inch. This radius is 2 inches. So I would put my transducer on here, and what I'll see, I will see a 1 inch and a 5-inch reflector. Pardon me, I'm sorry, a 1 inch and a 4-inch reflector. Because the sound goes, there's one, I'll get that reflector, that radius, 1 plus 2 is 3, plus 1 more is 4. So it comes up 1 and 4 inch. So I want to take a little bit of dB out here to bring my my 1 inch radius down to a manageable where I can see it on my screen. Like take out some dB, and using the peak memory on this machine, I can slide that transducer back and forth and see where that signal peaks. And right there is the peak of my signal. So I'm going to turn off the peak memory. So again, the peak, this zero marking is the beam index point, and I put a piece of masking tape on my wedge, and I transferred that zero marking to my wedge. That's your beam index point. All your measurements are taken from that beam index point. And the beam index point, that is where the majority of the energy coming out and receiving back to that transducer. I'm going to take that 1 inch radius, move it to 80% full screen height, auto cal. I'm going to cal, my cal mode is sound path, and it says cal 0, cal velocity. I'm going to press the P3, which is my cal 0, and I'm going to tell the machine what sound path that is. It's a 1 inch sound path. Just that. One inch, hit the check button, and then I have to move my gate over to capture my 4 inch radius. And by the way, while we're calibrating, there's kind of a dialog box over here. It says cal, C-A-L, and that means I'm in the middle of calibration. When I'm calibrated, we'll see that disappear. Let me take that 4 inch radius, that 4 inch reflector, up to 8% full screen height. Now I'm going to press P2, which is my cal velocity. Press that, and now tell the machine that that is a 4 inch radius, or a 4 inch sound path. And we'll hit the check mark, and it will calculate. Calibration is done. Move my gate over. This should be a 4 inch radius, and my sound path is indeed 4 inches. Bring it over this 1 inch reflector. Take that to 8% full screen height, and it is indeed 1 inch. Now I've calibrated the machine. Let's measure the angle. And the way we measure the angle is on the Rompus block, we have 0 degrees to 60 degrees on this line. What we'll do, we're trying to hit this side drilled hole, and that reading where our beam index point is, that will tell us what our angle is. There's also a 60 to 70 degree here, so if you had a larger angle, you would shoot it down this way. But first let me take the range and knock it down to about, let's take it down to about 1.5 inches because I don't need a whole lot of screen. I just want to give us enough screen so you can see it, enough latitude. So here's my beam index point. Here's the 45 beam index point, 45-degree angle. I'm going to put it right near there. I should see a reflector. And I do. I'm seeing a reflector right here. That guy coming up. Let me take him up to 8% full screen height. And there he is right there. That's side drilled hole. So let me hit the peak memory. And I go back and forth. Whoops, I slipped. Peak memory. I move that back. And this, by the way, this is just a mode converter signal. This is the actual signal that I'm looking for. Let me take that down a little bit. And let me again hit peak memory and try to peak this guy up. There he is right there. He's peaking. And at that point, I will look down here and measure my angle. And my beam index point that's marked on here lines right up with the 45 degrees. So this this guy is definitely a 45-degree wedge. So I don't have to make any changes to my trig function. If the angle was off slightly, change your angle here in your trig function. That way all your calculations will turn out correct.